Jai Hind everyone, I am Nikita Jaiswal and today I am going to discuss about topic dimensional analysis in course of fluid mechanics which having a code KC303. Okay, so what is this dimensional analysis? Dimensional analysis is actually mathematical technique of dimensions. Okay, so where we can use this dimensional analysis in case of obviously some research work and some experimental analysis where we use this kind of dimensional analysis. Okay, so simply it is a mathematical technique which make use of study of dimension as an aid of the solution of several engineering problems. And what is this engineering problems? What are the parameters which can be associated with some engineering problem? You know, any problem, just think of any one particular problem. Obviously when we are talking about fluid mechanics, then obviously this kind of problem which related to fluid mechanics, obviously that will be having some kind of parameters or variables. You can say variables may be a flow variable or velocity, acceleration. Many type of variables are there which are which depends upon flow property, and some of which depends upon the fluid property, and some of which depends upon the geometrical property. So there are many kind of variables in a particular phenomena. So that particular phenomena, if we want to get an equation for particular phenomena in which different kind of variables are involved, either dependent or independent, so this kind of engineering problems, how we can solve it? So this comes under dimensional analysis. So obviously it is used in research work for design or for conducting model test. In fluid mechanics, dimension analysis is useful in both analytical and experimental investigation, as written is here. Then testing of dimensional homogeneity of any equation of fluid motion. Okay, so dimension analysis is also can be used in case where we want to check if their particular equation we have written in a particular format is dimensionally homogeneous or not. We need to understand, we need to correct it if it is not. So first we need to check that that particular equation is dimensionally homogeneous or not. For an example, you can say 2 plus 2 equal to 4. We know that 2 is integer and 4 is also integer. What we are saying that LHS and RHS are same in form of particular variable. Okay, but again when we represent any kind of fluid flow problem or fluid phenomena in terms of variable, whenever we write an equation, for an example, you know, 3 equations of velocity v equal to u plus at, okay, where v is final velocity, u is initial velocity, a is acceleration, t is time. So any equation must be containing dimensional homogeneity. That means dimensions of LHS must be equal to dimension of RHS. So this is simple, this is, you can call it as dimensional homogeneity of any particular equation. Okay, and when we apply in fluid mechanics, we need to understand first what is dimensional analysis obviously, and what are the parameters that are going to be involved in that particular engineering problem. Okay, so what kind of parameters are there, what kind of variables, independent variables. So we are going to learn one by one. So in going further with dimension analysis, we need to first understand what is dimension. Okay, what are the basic dimension, what are the secondary or derived dimensions, we need to understand it. So the first is dimensions. Okay, first is dimension. The first topic in this particular chapter is dimensions. So we need to know that there are actually 3 fundamental dimensions. The first is mass, the second is length, and third is time. And in other cases where in particular phenomena, if heat transfer or temperature is involved, then we take another fundamental quantity as theta, or you can say it is as temperature. Okay, so the fundamental, actually we believe it is MLT only. This is your primary quantities, or you can say the primary dimensions. Okay. Now whenever we are going to write any equation for any variable, we are going to involve that M, L and T. Okay. For let us suppose MLT is what? M is what? M is mass, L is what? Length, and T is what? Simply time. Just for an example, when we are writing a dimension for mass, what we will write? Simple M. If we are going to write dimension for length, what we are going to write? Simply L. Okay. When we are going to write about a dimension of time, what will be that? That will be equal to time. Okay. Now this is simply, this is our primary dimensions or primary quantities. Okay. Now what is secondary quantities, or what is derived quantities? What we get from primary quantities, what we derive from primary quantities, it is your secondary, or you can say derived quantities. For an example, let us suppose volume. If you are going to derive dimensions of volume, what you will say? Volume is what? Area multiplied by length. What is area? Length multiplied by length. Okay. So what will be the dimension for your volume? Or you can say V equal to area multiplied by length, or you can say length square multiplied by L. So that will be equal to L3. And when you are going to write a complete dimension of the particular volume, what you will write as M0, L to the power 3 and T to the power 0. So this is how we can write the dimensions of any particular quantity. When we talk about area, area will be equal as L square, or you can say M0 L2 T to the power 0. Okay, because time is not there in a volume and areas formula, so obviously T to the power 0 will be there. When we talk about velocity, velocity is what? Velocity is simple. When we talk about velocity, velocity is what? Length divided by time. Okay. So you can write it as equation for velocity as by T. S is what? Simple length. T is what here? Time. Okay. Still mass is not involved in this particular formula. So what you will write it as? You can write it as M to the power 0, L to the power 1 and T to the power minus 1. So dimension for, or dimensional unit for velocity will be equal to mL T to the power minus 1. So this is a way you can find out the dimension of particular quantity or particular term. So what you need to do is just write the formula and abstract or derive what is the dimension of that particular quantity. Okay. The expression for a derived quantity in terms of primary quantity is called dimension of a physical quantity. Okay. So again there is an example written here, force equal to mass multiplied by acceleration. So mass is simply what? M. What is acceleration? You know acceleration, the formula or unit for acceleration you can say meter per second square. Okay. So L will be what? Your meter second square, that means per second square, that means your T will be your dimension for time will be T to the power minus 2. So obviously the overall formula you can see here as mLT minus 2. Okay. So in this way you can derive equation for, or you can say dimensional equation for particular quantity. Now okay, now what is dimensional homogeneity? What is dimensional homogeneity? As I have already told you about this in the starting of this particular lecture, that dimensional homogeneity actually states that equation which expresses physical phenomena of fluid flow must be algebraically correct and dimensionally homogeneous. Okay, dimensionally homogeneous, that means simply what? For any particular equation, LHS, dimension of LHS must be equal to the dimension of RHS. It is simple, you can call it as dimensional homogeneity. Okay, an equation is said to be dimensional homogeneous if the dimensions of the terms on its left hand side are same as the dimension of the terms on its right hand side. Okay, for an example, let us suppose velocity is equal to root over 2g. This is an equation, we know very well about it. Okay, so velocity, if we are going to talk about LHS and RHS, if we are going to talk about, or if we are saying that this equation is dimensionally homogeneous, what you need to prove, what you need to say, that the dimension of LHS must be equal to the dimension of RHS. Okay, so here LHS is what? Velocity. Okay, just write the equation or dimension for this particular velocity will be what? m0 L t to the power minus 1. Okay, now just go for RHS. RHS will be what? This is written as 2. 2 is simply constant, you can take it out. Okay, what is G? G is acceleration, again meter per second square, that means L divided by t to the power minus 2. Okay, and H is what? H is simply head, and head, again head you can write it as, this is T2, not T minus 2. Okay, this is T2. So this will be what? You just ignore the constant 2. Okay, so what you will get? L square by T square. This is plus actually. Okay, so what this will become? Obviously L by T, or you can say the dimension for RHS will be equal to m0 L t to the power minus 1. So here you can see the dimension for LHS is equal to dimension for RHS. So what we can say, that a dimensional homogeneity is exist in this particular equation. Okay, so dimensionally homogeneous equation can always be reduced to non-dimensional form. So okay, so next topic here we are going to take the methods of dimensional analysis. You see, when we know what are the fundamental dimensions, and when we know that how we can derive the dimensions of any particular secondary quantities, then here come how we are going to solve any particular engineering problem which contains a fluid, which contains many types of variables, many kind of independent, even independent variables. So how we are going to solve it? Obviously we are going to see some examples on this particular phenomena, how we are going to solve it. But there are two methods, two important methods to solve it. The first one, Rayleigh method, and the second is Buckingham Pi method. Okay, now we are going to discuss it one by one. The first is Rayleigh method, and proposed by Lord Rayleigh in 1889. Okay, so what it does actually, we use it particularly in case when we have variables ranging in between 3 to 4. Okay, if the number of variables is obviously less than 3, then we can take this Rayleigh equation and can find out what are the phenomena, or what are the equation involved in particular physical phenomena or fluid phenomena. Okay, the functional relationship of some of the variables is expressed in the form of exponential equation, which must be dimensionally homogeneous. Okay, for an example, let any fluid phenomena is having number of variables. Let us suppose from x1 to xn. Okay, this is xn to xn is actually your independent variable, and x is what? Your dependent variable. Dependent variables, what do you mean by dependent variable? Actually that x depends upon the values of x1 to xn. So when we are going to write any equation, we will simply say that x is equal to function of, in bracket, x1 to xn. Okay, Now what the next step, what will be the next step in this particular case? What will just convert this function to this kind of equation. Here you can see that the particular dependent variable is now equal to c, where c is constant, and x1 to the power a, x2 to the power b, x3 to the power c, and dash dash xn to the power n. Okay, so what is this a, b, c and n? This a, b, c and n are actually we are going to derive it. We are going to find the values of this a, b, c and n, so that we can find out the particular dimension, okay, for RHS and obviously for LHS also. Okay. C is what? C is simply a dimensionless constant which may be determined from the physical characteristics of the problem or from experimental measurement. Okay. The exponents a, b, c, d is, it is what? Exponents are obtained considering dimensional homogeneity of the equation. Now we are going to discuss this relay method by taking example. Okay, this is written here, the problem 12.2. So actually I have taken this example from your book R.K. Bansal, Fluid Mechanics. Okay, so just we are going to understand the question and we are going to solve it. Okay, simple. Now you can write that the time, here you can see the time period for time period t of a pendulum depends upon the length of the pendulum and acceleration due to gravity. Okay, derive an expression for the time period. Simple. Question was just the question, the particular fluid phenomena is simply saying the time period of any pendulum depends upon the length of pendulum and acceleration due to gravity. Okay, you cannot relate it to actually a fluid flow problem, but just a simple equation we are going to solve it. Now the question is asking for derive an expression for the time period. Okay, when they are asking for deriving an expression for time period, that means here time is your dependent variable and the other are your independent variables. Okay, so when we are going to write an equation, we need to first identify what is dependent, what is independent, and which variables are involved in that particular phenomena. So here we can obviously identify 3 variables are involved in this particular phenomena. First is length, then gravity and time. Okay, time is dependent variable. So when we are going to write equation for time, so obviously we will write t equal to function of L and G. Okay, the next step for solving this particular kind of question is what? Simply just convert in a form of relay equation that will involve a formulation that involves a dimensionless quantity, that is k. You can write it k or c, whatever you want. Okay, I am writing or I am taking it as k. Okay, then in bracket you can write it as L with an exponent a and multiplied by G with an exponent b. Okay, where k is obviously k is a constant. Okay, now just what you have formulated a equation. Okay, now you need to figure out what are these exponents a and b, and we need to equate the dimension of LHS and RHS. Okay, so just you can see substituting the dimension on the both side. Okay, when you are going to write the dimension of time, this will be equal to your t only. K is constant, so you do not need to consider about this constant. You go to you jump to this element L. Obviously the dimension for L is simply L. Okay, and dimension for G, we have just discussed about the dimension for acceleration is what? L t to the power minus 2. Okay, so just write all the dimensions of all the quantities involved, then t will be t to the power 1 will be equal to k L to the power a, L t to the power minus 2 whole to the power b. Okay, Now the next step, you need to just equate the dimensions. Okay, these dimensions. Here you can see t to the power minus 1, t to the power 1 is only there. That means m will be 0, m to the power will be 0, m to the power 0, and l to the power 0 and t to the power 1. Okay, so just you need to uh, uh, equate the powers of fundamentals. Okay, when you are going to equate the powers of time or t, you will get 1 equal to minus 2b. Okay, here you can get b equal to minus half. Simple. Now just equate the powers of L. Powers of L you can get in that particular equation, 0 equal to a plus b. Okay, so here you can see a will be obviously minus b and b is what? Minus half. So a will be equal to your half. So just substitute the value of a and b in particular equation. You can get it as t equal to k l to the power half multiplied by g to the power minus half. So this will be equal to your k whole to the power l by g. Okay. The value of k is determined from the experiments which is given as, if that particular equation is containing constant value, then you can take or you can write the answer as k equal to 2 pi. But if it is not given or it is not it is not known to you, then you can write k as k. Okay. Now next you can write the final formula. T or time period for a pendulum will be equal to k or 2 pi root over L by g. So this will be your final equation, or this will be your derived expression for time period. Okay, in this particular phenomena. This is not directly related to a fluid problem. This is not directly, or but you can still imagine, because the pendulum is is revolving under the surrounding of air. So there is some you can imagine that it is. Now we are going to the next question. Find the expression for power developed by a pump where P depends upon the head and discharge and specific weight of the fluid. See, when the related variables in particular phenomena is less than or equal to 3, you can take Rayleigh equation. Okay, when it is not equal to or less than 3, we are going to Buckingham Pi theorem. Okay, in this particular question you can see what is simply written as or given as the power is dependent variable, and it depends upon what? Head, discharge. You can see here head, okay, sorry, head, discharge and specific weight. Okay, so you can write the formula as P equal to S to the power A, Q to the power B, specific weight, or W to the power C, and you can multiply here a constant as capital K. So K is your non-dimensional constant. Okay, now substituting the dimension on the both side of the equation, what you will going to get it as P. The dimension of power is what? You need to derive it, or you need to remember what is the dimension for power. It is m l to the power 2 t to the power minus 3. Okay, now head, the dimension for head will be what? Length. The dimension for q, okay, dimension for q will be what? Volume divided by second. That means l to the power 3 divided by time, or l to the power 3 t to the power minus 1 will be the dimension for q. And specific weight, you know what is specific weight? Just derive the or write the equation for specific weight and derive what is the dimension for, will be for specific weight. So the dimension for specific weight is written as m l to the power minus 2 t to the power minus 2 whole to the power c. Okay, so here after writing the equation, you can equate the powers for m l t on the both sides. After doing that, you can find out the values of different exponents. Here you can get c equal to 1, a equal to again 1, and b equal to 1 2. So after writing all the values of exponent in that particular equation, what you are going to get as power equal to k, where k is constant, k multiplied by h multiplied by q and multiplied by specific weight. So this will be the answer for this particular equation. Okay. Now there is another question. Okay. There is another question which involves a lot of variables, but okay, we can try it by solving by relay method. Here you can see that the resisting force R of a supersonic uh, plane during flight can be considered as dependent upon the length of the aircraft, L, velocity V, and air viscosity mu, air density, bulk modulus, and express what the question is asking. Express the functional relationship between these variables and the resisting force. Okay. So simply we are going to write the equation between the dependent and independent variables. Okay. Here the dependent variable is what? Simply resisting force R. Okay. We are just going to write the equation involving constant S. Now I am taking the constant as A. So this will be what? A L to the power A, V to the power B, nu to the power C, rho to the power D, and K to the power E. Okay. On the next, the step will be the same as we have discussed in the last previous questions. Steps will be the same. We need to just write the equations for or dimensions for the particular quantities, and we need to equate the powers of M, L, and T. Okay. In this question also, resisting force, we have written the dimension for M, L, T to the power minus 2, L to the power A, and V, L to the power minus 1 to the power B. And this is what your nu, rho, and K. Okay. By equating the powers of MLT and by solving all the terms, you will get as final what? D equal to 1 minus C minus E. B is simple your 2 minus C minus 2E. Okay. Here you can see that this kind of equation is going to be a complex phenomena. Okay, this is complex problem. That's why we consider that when a particular phenomena is involving parameters greater than 3, then we do not usually prefer to solve it by relay method. We go for Buckingham method. Okay, here you can see that D is having 2 variables again, B is having 2 variables, and A is again having 1 variable. Now in this particular if we are using this method, now on the next what we are going to do, we are simply writing all the equations we got for A, B, C. Okay, we have just wrote as we got. So we are just taking L square as common, V square as common, rho as common. What written, what left in that particular bracket is L to the power minus C, V to the power minus C, nu to the power C, and rho to the power minus C. So what you will get as, on an average, in bracket, nu divided by rho VL whole to the power C. Okay, and the next term you will get K divided by rho V square whole to the power E. Okay. Still we do not know the exact value for C and E because we have adopted relay method. So what you can simply write it as, this must be a function or functional relationship between these two parameters. So we have just written here as phi, or you can say function, in bracket of these two terms. So when you are solving by relay method, you cannot get when there are many variables greater than 3 or 4 variables are involved, you cannot get the exact power, exact equation or exact value for exponents, all the exponents. So you can formulate the final formula like this, or final expression like this. Okay. So now we can talk about Buckingham Pi method. What is this Buckingham Pi method? It actually involves number of pi terms. These pi terms are actually dimensionless. Okay. There are the relay method was actually a simple method. This method is a little bit lengthy process, but a little bit lengthy method, but it gives almost accurate equations. So what is this Buckingham Pi theorem? What it states? It states that if there are n number of dimensional variable involved in particular phenomena, which can be completely described by m fundamental quantities. Okay, m fundamental quantities what? Our 3: mass, length, and time. and are related by dimensionally homogeneous equation. The relationship among n quantities can be expressed in the terms n minus m dimensionless and independent pi terms. First, you need to understand, let us suppose any physical phenomena contains, let us suppose, 5 terms, including dependent and independent variables. Okay, so n will be equal to your 5. What is m? M is your fundamental quantity mlt, which is what? 3. Okay, so n minus m will be what? 5 minus 3, that will be equal to 2. That means you need to formulate 2 pi terms. Okay, 2 pi terms, that will be equal to your pi 1 and pi 2. So you need to formulate that. Okay, so we are going to discuss it directly in any numerical. Okay, obviously when we write mathematically, if q1 depends upon q2, q3, q4, qn, obviously you can write the formula as q1 equal to function of q2 to qn. Okay, so here you can see as where c is dimensionless constant, or we have just formulated c equal to f1 q2 qn. Okay, so we are going to discuss it by using our numerical. Here you can need to remember that this particular equation can also be written in this particular form, where function of what? Pi 1 to pi n minus 1 equal to c1. This will be the equation, this will be your equation. We need to going to solve it by using Buckingham Pi theorem. Okay, so here we are going to formulate, we are going to choose some variables involved, and how we are going to, there are some repeating variable, there are some non-repeating variables. So how we are going to solve it, how we are going to discuss it further, will continue. Obviously here it is written as each pi term is formed by combining m variables out of n variables. Obviously pi terms will be equal to your n minus m. Okay, some m variables that are called repeating variables, and that can be chosen in particular fluid phenomena. Okay, and here you can see the pi 1 will be equal to your q, you can take any quantity q 1 to the power a1, q to the power b1. Okay, so this is a way to write formulas for pi 1, pi 2, pi 3 to the to pi n minus 1. Okay, so we'll discuss further in next lecture. Okay, we are going to solve, we are going to take an example of this Buckingham Pi method, how we can solve it by using Buckingham Pi method. So overall summary for today's lecture is what are the dimensions, what is dimension analysis, what is dimensional homogeneity. Okay, and what we have learned, that how there are different methods are there, and how they can be differentiated, and which kind of number of variables, how that can be involved, how that can be solved. So there are two methods. We have done the introduction of Buckingham Pi theorem, and we have done the introduction plus numericals of Relay method. We are going to uh, continue this topic in next lecture. Thank you. Jai Hind everyone.